Hey folks, it's Mr. Murray coming to you with a video on SOCS in dot plots. And so in this video, what I'm going to be doing is I'm going to be talking about shape, outliers, center, and spread, which is what SOCS is. And I'm going to be doing this focusing on examples involving dot plots. Okay, and so this is part of a 3-video series on different examples with SOCS, with dot plots, histograms, and box plots. Okay, so remember again, SOCS stands for shape, outlier, center, and spread. And hopefully by the time you're watching this video, you know what those mean and how to find them. If not, go back and take a look for that. So here is a dot plot right here. And in this dot plot, we have a nice little distribution of data. And so what we're going to do is we're going to do the shape, outliers, center, and spread. Now, before I do this, I do want to just reiterate the idea that SOCS some things are definitely not open to interpretation and some things are. And it kind of depends on your particular dot plot. And so for me, in terms of when I'm grading, as long as you give a reasonable interpretation and your interpretation is supported clearly by the data and the facts, I'm open to being flexible with your answer, because for me it's not about nitpicking the technical stuff. It's more, kind of helping you really be able to clearly analyze data and kind of giving you that valuable feedback there. So here, the shape. So the shape, we can see that we have some data off to the right. And what that data is doing is it's skewing the mean. So it's pulling the mean up. It's making the mean relatively larger than the median, right, the middle. But the numbers you see off to the right, they're not really representative of the data at large, okay? And so the kind of shape we see here, okay, is we say the data are skewed right. Okay, remember data is plural, right? And there are multiple points, multiple data points, right? So the data are skewed to the right. Okay, outliers. So remember, outliers, I'm going to let you kind of use your kind of instincts. I know that's not really necessarily mathematically okay. In course 1, that's going to be fine for now. If you decide to take some kind of like AP statistics or more advanced statistics class, you should be prepared to be a little bit more mathematically rigorous when you talk about the outliers. So just be aware of that. So here, I'm going to say there is one outlier, which is 9. All right. So the data are skewed to the right. And when the data are skewed, you're supposed to use the center. For the center, you're supposed to use the median. Okay? And the reason that is because the median is always the number directly in the middle. Okay? So the median is always bigger than half of the numbers and smaller than half of the numbers. So it's a good way of thinking about a center or an average. So because the data are skewed, right, like I said, the mean isn't really necessarily a good measure of that center. We want to use the median instead. So we're going to systematically find the median. Now, there are ways that you could use a calculator to do this, and if you know how to put the data into a calculator or into another thing and calculate the median, you're totally welcome to do that as well. I'm going to do it the more rigorous way of, since the numbers are already in order, I'm just going to cross out. Boom. Okay, and we can see the median is going to be somewhere here. Okay, and it matters that that's the middle number. Okay, so this is how I expect Course 1 honor students to write this statement. Since the data are skewed, the median of 3 represents, sorry, I was just trying to get the best word there, the center of the data. Okay, so in Course 1 Honors, I'm expecting 3 things. You have to make 1, a mention of the measurement you're using. So I specifically said I'm going to use the median. You have to tell me what is the measurement, right? Because if you don't give me a number, then it's like I use the median. Well, like, so what? What is that, right? So you have to give me the what measurement. You have to tell me what was it? What was the actual number? 3. And you have to tell me why. Because it matters which one you use. One is reliable and one is not. And I want to understand your reasoning. And it's just a matter of saying, I used it because the data was skewed. Okay, perfect. That's fine. That's exactly when you're supposed to use it. So again, what measurement did you use? What was the value? Why did you use it? You can say however you want, and I'll show you another way I'm going to say it, as long as those 3 things are there. Spread, we're going to do the same thing. Now, because it's skewed, the spread is going to be the interquartile range. So I'm going to use the old-fashioned way, so to speak, and I first need to find the Q3. Now, remember, if your median is in the data set, that number, so the number that I circled there, that 3, does not count when you're finding the interquartile range. So here we go. I'm going to find the median first of the numbers that are bigger. 1, 2, technically I guess I've been this one, 2, and then we're going to end up somewhere here in the 4. So quartile 3 is going to be equal to 4. And if you look at it, this 3 numbers are bigger than 4, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, about 12 numbers or less. So a lot of the numbers, the majority of the numbers, about we'd say 75%, are going to be lower than that particular value. Okay, if we broke that down. So, all right, that's our Q3. Now we're going to go the other way, and we're going to head on down, and we're going to cross this, 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 this. I think we're going to be stuck. I believe the quartile 1 is going to be 1.5. Okay, so let's say that's what we'd get. Now we're going to get the IQR. So remember, the IQR, the interquartile range, is always Q3 minus Q1. So that would be 4 minus 1.5, which is 2.5. 4 minus 1.5. Okay. Okay, so we're going to say since the data are skewed, the interquartile range, and you can just say IQR, of 2.5 represents the spread of the data. Okay, so again, the measurement, IQR. What was it? It was 2.5. Why'd I use it? The data's skewed. Okay, so really important. So folks, that's just a quick breakdown. I know this one was a little bit longer than I usually do it. The next one, will continue to go faster. So please take a moment, make sure you understand where I got these from, and then in a second I will move on to the next example. Okay, so example 2, and again, we're going to start by laying out our shape, outliers, center, spread. Here we see the opposite. So here we see that there are numbers kind of more off to the left that are pulling the data down. So here I'm going to say the data are skewed. Now we're going to say we're skewed to the left because the data is off to the left. Here, though, I'm going to say I'm not convinced. So I'm going to say actually that there are no outliers. Some might say 2 is an outlier. I think you'd have a tough time making an example, making a case for that. If you do the test with the fences, the upper and the lower fence, it definitely won't work there. I can say that pretty safely without doing the math. To me, when I think of an outlier, if let's say this 2 was a 0, I could buy that. I would really struggle to get on board with you there. So if you are gonna say 2 is an outlier, you might have to really say more than that in the sentence, because you really gotta you're right. You got the burden of proof, so to speak. You gotta sell me. You gotta really show me the evidence, right, and convince me. So just saying. Center. Now the data are skewed, so again we're gonna have to find our median. So let's go ahead and do that. Boom, boom, 4. It's okay to go back to the basics. 7, 9, 7, 8. So it's going to be one of these 8s, and then these 8s would cancel, so it's going to be the middle 8. So the inner circle represents the true median. So since the data are skewed, I used the median of 8 for the center. Not the exact same wording. That's fine. All right. So that's that. Let's get the IQR, because that's what we would do next. So again, this one doesn't count. So this one's going to take a little bit more time. 10, 9, 10. So it's going to be somewhere between 9 and 10. Now, I'm not certain of this. I'm just going to do this real quick. What it is necessarily right now, the actual IQR, if I'm off by a little bit, let's not worry about that. Right now, what I want to focus more on is SOCS. How do we actually analyze it, right? That we tie the IQR to it because it's skewed. All right, let's do it the other way. So we got 1 here, 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 1 here. And I think we're going to have one more 5, one more 6. So let's say it was, I don't know, 5.5. If it was really between 5 and 6, that's what we'd have. So the IQR is going to be the Q3 minus the Q1. That gives me an IQR of 4. Okay? So then I say, since the data are skewed, I used the IQR of 4 for the spread. All right. So hopefully this made sense to you folks. Again, please feel free to rewind, pause, go back, take a look at anything. And then in a moment when you're ready, you can go ahead and move on to the last example. All right, last one. So this is an interesting one. So we did a survey of a class. We want to know about numbers of brothers and sisters. Here we can see that the data are actually here. This data are symmetric. The data are symmetric, okay? And that's the way that they're arranged, right? You can see a 2, a 3. It's approximate. It's not perfect, but it is, if you think about it, if you take 3 and kind of think about a reflection, you can see how they'll go right on top. So nice symmetry there. Not all data looks symmetric, but a lot of data, if you take more advanced statistics, you'll learn this idea of symmetry really underlies more than you'd think. Outliers. Here, I'm going to say there are no outliers. Alrighty, center. So the center, what we're going to do is we're going to use the mean. So to do the mean, what we're going to do is we're going to now turn to our calculator to help us figure out the rest. All right, folks, here we are in our calculator, and I'm now going to show you how to do it with the TI 84 Plus CE. So first, we're going to go to Stat, where our stats are. Then we're going to hit Enter, or 1, to go to the spreadsheet. Okay, my spreadsheet is blank. Yours might not be. If it's empty, just hit the up arrow so that L1 is highlighted like you see here. Hit clear, and that's going to clear out anything that's currently in there. And then to confirm, hit enter. If one of them went away and you don't see an L1, try hitting stat, going down to setup editor, and then hitting enter so it says done. That usually fixes a lot of those issues. So now I'm going to type in each of my numbers one after another. So I've got 2 zeros. I've got 3 ones. That's what the dot plot says. I've got 5 twos. I've got 3 threes. And I've got 2 fours. Now, this suggests that I've got 15 numbers total. L1 15. Let's double check that. 2, 5, 10, 15. Perfect. That's a good sign. So to do the stats, I'm now going to go to stat. I'm going to go over to calc. And I'm going to do one variable stats, option 1. And I'm going to use list 1 because that's where I put my data in L1. Usually you don't have to worry about this as long as it says L1, and you're going to just do calculate. Okay, this will usually take your graphing calculator a little bit more. Since this is based on a computer and my computer is a little bit more powerful than a graphing calculator, this is done a little bit faster. Okay, so mean. The mean is the thing that's an X with a bar over it. It's this first one here. Oh, that just blew up real nice. Oh, nice. Okay, so let's take a look now that I can get this little screenshot. So the mean is this X with the bar over it. And the little O with the thing, that is what we want for our standard deviation. Okay, so since the data are symmetric, I used the mean of 2 for the center. Okay, and now finally, since the data are symmetric, I used the, and you can say standard SD, standard deviation of approximately 1.2 for the spread. Okay, so again, I see measurement, I see the actual value of the measurement, and I see a reason. Okay, so it's based on the facts. Okay, it's about facts. So those are 3 quick graphs, folks. 3 quick dot plots where I've broken down SOCS for you. And it's just a matter of, again, identifying the shape, looking for any outliers, and then using what you know about the shape for the center and the spread. Look, it's always that breakdown, right? Skewed is always median. Symmetric is always mean. Skewed is always IQR. Symmetric is always standard deviation. It's the same breakdown every time, right? And hopefully as we do more examples, we'll become a little bit more confident. So best of luck, folks. Don't forget to love math. And remember, you can do it. Until next time, have a wonderful day.